All right. And I'm going to turn it over to the great Jim Albert to take us away for the remainder of the session.
Okay, thanks. Yeah, thanks, Ron. It's fun to be here. I was here a number of years ago. I can't recall how long ago, but.
I think I was a first-year PhD student, so it's a long time ago.
Okay. Okay. Anyway, so I was really impressed by David's interactive coding. I want to do a little less of that. So what I've done here is I prepared a single Quarto document, and I'm going to focus on probably, if you ever take a course in sabermetrics, probably one thing you'll definitely hear about is what's called the runs expectancy matrix. And so I thought I would talk about how to do that, and that's described in chapter 5 of our book. And so I'll try to go slowly and explain the background of this thing, and explain. It's relatively easy to produce, and then we'll talk about some applications of it afterwards. So, okay. So let's see. So, and actually, this idea of run expectancy is really an old concept. And back in 1963, there was a paper by George Lindsay, an operations research paper. And what he did, he was interested in basically the potential to score runs in an inning. And so now those days, this is like late 1950s. Where was the data? Well, his dad actually was sitting in the stands recording all this play-by-play data. So his dad collected all. I can't imagine how many games he watched, but a lot of games. Anyway, so really the first run expectancy matrix was produced by George Lindsay, and it's really been a pretty stable, it's still a very important concept. It's used to evaluate different types of hits, evaluate strategy, like should you steal, should you take the extra base? You can basically look at all those things from the viewpoint of runs expectancy. And this is, okay, you define a state of an inning by looking at a half inning of baseball. So in a typical baseball game, you got 18 half innings. And so you look at the runners on base. Each base could be occupied or not. So there are 2 times 2 times 2, 8 different possibilities for runners on base. The number of outs could be 0, 1, and 2. So there are 24 different states of an inning. Okay. And so what you record, what you want to compute is the expected number of runs in the remainder of the inning. Okay. So what you want to do is for every single play, you want to record how many runs will be scored in the remainder of the inning. And eventually you average those things over all the half innings. Okay. So, and fortunately, this kind of data that you can use is Retrosheet is a public effort to record play-by-play data, and that data is free. You can download it from retrosheet.org, and then there are programs they're called the Chadwick programs to basically process those files and create these Retrosheet files. And so I'll be using a data set for one complete season. Now, more recently, I think Scott Powers has a different method now of extracting this kind of data. But anyway, it really is, it's very good data, and it allows us to compute this matrix. Okay, so here's an example of what this matrix looks like. And this is this is a graph from Fangraphs. And you see you have the runners on base along the rows, and you have the number of outs. And it gives you, again, this is so for example, when the inning starts, the expected number of runs in the remaining inning is 0.461. You may ask, how can you score 0.461 runs in an inning? That's sort of hard to do, but that's an average over all half innings. And so obviously the most important, so for example, if there's bases loaded with no outs, then you score an average of 2.282 runs in the remainder of the inning. Okay, so we want to produce this table. Now, and so what I have on my website, in my GitHub folder, is this file. So if you want to run this analysis, all you have to do is just download this one file. And this is the location of the files. And again, this is sort of a stepwise look at what we're doing in chapter 5. Okay. And there's also, and actually one thing about the book is you don't need to buy this book, okay? Because it's completely available online, the 3rd edition. And if you want to buy it, I think it's currently 20% off at Amazon, but that's just it's a side issue, but but anyway, I'm surprised they kept it 20% off. I thought they would have gone back to work. Amazon, if you ever have a problem with Amazon, I don't think there's a customer service. You don't call, do you ever? I had a funny thing where one of my books, there was some weird thing that happened in the book where they printed some weird stuff in the book and we wanted to stop the printing. And so it disappeared from Amazon. It was hard to get the book back on. So again, you just don't call somebody and ask them what to do. Anyway, okay, now connected with our book, there's a package called ABDWR3E data. And this contains some data sets and some functions for doing things in our book. I'm not using that package in this, what we're doing today, okay? And so we're just going to use a couple of functions. And also in our book, I think we use 2016 data from RetroSheet. I'm going to use more current data from last season, 2023. And it turns out that these run expectancies values don't change much from season to season. And I'm going to be also using 2 functions I wrote. One is from our book called RetroSheet Add States, and one is called RePlot. And I'll describe what these functions do in a bit. Okay, so what we'll do is I'm going to read in 4 packages. We've already seen dplyr from David's talk. I'm going to use readr package to read in this data set from my GitHub site. tidyr is a package within the tidyverse system. tidyr will be helpful for, basically we want to have a long data set, we want to make it a wide data set. We want to pivot the data set, and tidyr allows us to do that. And of course, we're using ggplot too. So in this chunk of R, I'm going to load in these 4 packages. I'm going to read in these 2 functions. Okay, and it's doing that, I think. And now I'm going to read in the RetroSheet data. And I'm reading this directly from this is not the complete RetroSheet data for all the variables. It's just the ones we're using, so it's a subset. So I can store this. Okay, and it's reading it now. And so basically you have 190,390 rows. Each row corresponds to 1 play in baseball. Now a play in baseball could be a batting play, it could be a stealing play, it could be a wild pitch, could be, we saw in the World Series, a catcher interference. That was one of the, we won't talk about that game 5, but of course anyway, I'm a Phillies fan, but I also don't like the Yankees, so I was enjoying game 5, especially the fifth inning, Okay, I almost turned it off too, because Cole was doing so well, Anyway, how could they lose? Okay, so I'm reading this data set, and okay, so the first thing I want to do, this is a small clerical thing. The RetroSheet data set, it turns out that I think the way it's defined when you run these programs is that all the variable names are uppercase, and Ben likes lowercase variable names. So we're going to make sure all the variable names are lowercase. And it didn't like that. Okay. And now, okay, so we have this data set with lowercase names. Now, the first thing I want to do is we're interested in the expected number of runs the remainder of the inning. So we have to know, at a certain play, we want to know what the current score is. And we also want to know how many runs are scored on that play. Okay, so in order to compute so I'm going to compute a variable called runs before, and we're just going to add the current away team score and the home team score. And we're going to compute a thing called run scored. And basically, we want to know where the runners go. And the runners make it so there's four variables. One is called bat destination ID, run one destination ID. These tell you where each runner and the batter go after the play. And so if the batter destination ID is 1, it goes first base, 2 is second base, 3 is third base. If it's bigger than 3, that means that runner scored. So basically, we're going to check to see if each runner, including the batter, makes it to home. And we add those up, and that's the total runs scored in that play. And then also, eventually, we want to have an ID for each half inning. And we can create an ID by using the game ID. That's a unique number for each, or a unique variable code for each game. Then we also have the inning number and also the bat home ID. So bat home ID will be 0 for that's for the visitors side, and 1 will be in the bottom of the inning. So that's going to basically create a unique code for each half inning. Okay, I'll do this. Execute this chunk. Okay. And so now, by the way, if you want to look at this, well, I don't need to look at it, but so it's create these two new variables. And so the mutate function in dplyr is used to create these variables. Okay, so so we have 3 new variables. We have the half inning code. We have the runs that were currently run scored, current score of the game, run scored, and also we have how many runs are scored on that play. Okay, so what I'm going to do now is I'm going to, for each half inning, I want to compute the number of outs in the inning. Now, obviously, that's sort of silly because we know that every inning has 3 outs. Well, not exactly. There are situations in baseball where you can end the game and have only 2 outs or 1 out or 0 outs, right? So that's why we want to record the number of outs in the inning. We don't care. We want to only talk about runs in the rest of the inning only for the complete innings. We want to discard the rest of them. Okay, then we want to compute for that half inning the total number of runs scored. We want to compute the runs that were scored at the beginning of the half inning. So by using the variable called first, that'll pick up the first value of runs. Basically, it's like the total runs scored at the beginning of the inning before any plays. And also, we want to record what's the maximum number of runs scored. Okay, so you take the beginning run scored on the inning, and then you want to basically, you take the beginning, which is run start, and add the total runs of the inning. And that'll be the maximum runs. So we're recording that for each of the half innings. Okay, so we have 2 data sets now. We have the retroshoot data, which is all like 190,000 rows. And now we have a data set which gives you some numbers for each half inning. We want to merge them, okay? And there's a nice function called inner join. That's in dplyr, which allows you to merge. Okay, so what this says is that for each, you want to merge the half innings data frame, and then merge that with the retro data, which is our retroshoot data. And we want to merge it. Our key thing that will connect those 2 data sets is the half inning. Okay. So now that information about the half inning is added to each one of the rows of the retroshoot data. And now here's the key variable. The key variable is how many runs are scored in the remainder of the inning. And that's called runs.R01. And you're going to take the maximum runs that are scored in the total inning and subtract the runs that are before. That'll tell us how many runs there are in the future of that half inning. Okay. And so once you have that, you really have all the information you need. Didn't like that. I clicked on the wrong thing here. Okay. So now what we have is we have for each play, we have recorded the number of runs scored in the remainder of the half inning. Now remember, for our table, we want to compute the average run scored in the remainder of the inning for each state. The state is defined by runners on base and number of outs. I don't have those state variables recorded. So we created a function called retro sheet add states. You probably can guess what that does. It adds two state variables to each play. It tells us what the beginning state is, number of outs, and the runners on base, and tell you what the final ones are. And this function, you can look at it online. You can see what it does. It's not really that exciting, so I'm not going to show it to you, but that I'm just going to apply that. Okay. So now we have, and by the way, these state variables are these are like little codes where 0 corresponds. You'll see what these things look like in a second. So we have the beginning state and we have the end state. Now we only want to consider the plays that either change the state or runs are scored in the play. Okay, because there are some times where nothing will change. I guess what would be an example of that? Maybe like a pass ball, maybe. Sometimes things won't change. You don't care about those. So what I do here is I'm going to take the data set and remove the times. I only want to consider the cases where the states are different or runs are scored on the play. And basically this says state is not equal to new state or run scored is positive. I'll run that. And also, we only care about the innings that are half innings that are complete with 3 outs. There are a few cases where there are 2 outs or fewer. We want to remove those and only consider the cases where the outs are 3. Okay. And basically we're done, because now all we want to do is summarize this retro sheet data set. So what I want to do is for each state, each beginning state, which is defined by, again, it's runners and base and outs, we want to compute the mean runs the remainder of the inning. So, and our beginning state is defined by bases. Bases would be like a 3-digit code, like 100 would mean runner in first, 110 would be runners in first and second, and then we have a count of outs. So what I'm going to do here is I'm going to group my retro sheet data by the bases, who's on base, and number of outs. And for each of those groups, I want to compute the runs in the expected inning. I'm calling mean run value. And for some reason, I'm also going to find the opportunities. So some states are more popular than others, like no runners in base and 0 outs. You know, that's sort of a boring time in baseball. Bases loaded, 1 out, 0 out. That's pretty exciting. Okay, so I want to do that. And this will compute my matrix. Now, if you printed this matrix, let me just print that. I want to display it. Well, there it is. So for example, here are the different base values. Here's the number of outs. And this is the mean run value and the opportunities. Now, this is fine, but it's not exactly the way we like to see it. We want to see it like they show in fan graphs, where you have rows and columns in like a matrix. So I want to reformat this information so that it's more meaningful. And so what I'll do now, this is where we want to do some pivoting using the tidyr package. And what I'll do here is I'll take the expected runs. We're going to focus on 3 variables: the bases, number of outs, and the expected runs, the mean run value. We want to pivot it so that the values will be mean runs. And this is a kind of one of those things in tidyverse, the pivot writer. I don't use it enough, so whenever I use it, I have to look it up, to figure out what to do with it. Anyway, so I run this, and I get there's my matrix. Actually, usually it's recorded to usually I do 3 decimal places or 2. I do that, right? So maybe I should, let me do that. I'm going to do something naughty here. I'm going to use base R. I have a colleague at Bowling Green who's anti-tidyverse.
There's a lot of anti-tidyverse people out there.
So we like ggplot, but I don't consider ggplot part of tidyverse. So. Okay. And then I'll just change this to. Well, I don't round it to that. I want to round it to 2 decimal places. Sorry. I wasn't planning on doing anything on the spot, but I was so inspired by David's work.
Do it live is our theme.
Is that your theme? I used to teach data science. Yeah. See.
You just replace with that new column degree, right?
Oh, I didn't select the right ones. Oh, I used the wrong.
Just grab mean values.
Oh, yeah. Lost it. Like either.
It's in the values from. You gotta check.
Oh, yeah. Glad Ron is here. All I was trying to do is just round it to the 2 decimal places. That wasn't too exciting. That works, Okay. Okay, so a few years ago, now I don't know if you know or not, but when I'm retired, so to keep me busy, I play tennis about 5 days a week. But when I don't play tennis, I get to dabble. So Max and I had this idea that we would write this blog to sort of add to the book, right? And so we said, okay, we would take turns and post on this exploring data using our blog. And so what happens? Well, Max got hired by the Indians 2 months later. So, but anyway, so that wasn't too good. So anyway, I ended up I've had, and Ben helped somewhat, but basically it's been a one-man show, and I can't tell you how many years I've been posting on that blog. Too long.
Yeah, I was an undergrad, so that was a long time ago.
Yeah, I think I have 392 posts or something. It's ridiculous.
I still go to the one that tells you how to do the spray angle calculation to put it in the right direction.
Right.
Yeah.
Well, the only tricky about doing these posts is that sometimes I got to look at what I've done, because often I do the same thing again, and I say, well, I probably shouldn't post the same thing twice, and so I have to, like a little thing in my mind, say, maybe I did something before like this, and Anyway, so when you look at this table, this is not a graph, right? This is a table. If you look at my blog, I don't show tables very much. I like to graph things. There's a graph in practically every one of my posts. So I want to graph this information, right? How? How do you graph it? Well, what I want to do is I'm going to define a new variable called basis score. And what you do is you add 1 for runner in first, 2 runner in second, 4 runner in third, add them up. If you do that, then the 8 different options go from 0 to 7. That's nice. And then, so what I'll do then is I'm going to graph it. And basically what I'm going to do is graph the run expectancy versus the basis score, where I use a different color for each number of outs. That's basically what I'm doing here. The code isn't very exciting, but you get this nice graph. Maybe not. There it is. Okay, there's my graph. So basically, it shows you that generally the runs expectancy is roughly a linear function of the basis score, but the intercepts and the slopes vary by the number of outs. Okay, so that's nice, right? The next thing you want to do is you want to actually find out the equations of those lines, right? So we want to fit a model. We want to basically fit a model to this data. Now, in ggplot, I don't need to find the formulas. It just does it for me. I mean, it's just one of the, I'm essentially using one of the smooths it does. I mean, there's a geom smooth, and you can specify a nonlinear smooth like what's a nonlinear smooth? Like Loess, not Superman Loess, but L-O-W-E-S-S, Loess. Bill Cleveland's Loess. Anyway, and then you can do it that way, but also you can fit a line. So I want to basically find the, by the way, here's the data I use in this. So basically it shows you the basis outs, mean run value, and then shows you the basis score on the right. Okay, so so to summarize this graph, I want to fit a model. And so what I do here is I'm going to use the most popular, by the way, if you, before there was R, we had S. In fact, when I was at first at Bowling Green, the first interactive language I used was S. S was a Bell Labs software program, and much of R was borrowed from S. And one of those most popular functions that S had was LM. So that hasn't changed. It's still there. So basically, you're doing a linear model. The response is mean run value. And essentially, you want to fit a different line for each number of outs. That essentially is an interaction model. And you specify the interaction model by going outs $ basis score. Okay, so here I do the fit, and then I want to extract the coefficients. Okay. And I want to put that in a table, so I'm just going to put it in a table. And there it is. Okay, so now we can interpret that graph that I showed you. And so basically what that says is that when there are no outs, they're roughly 0.46 runs in the remainder of the inning. Every additional basis score will increase the runs by 0.23. Okay, that's the slope of that line. When there are two outs, the expected number of runs is 0.14. That's with no runners on base. Every additional increase in the basis score will increase the runs by 0.08. So that's a nice summary, okay, of that information. So, okay, now I think Tom Tango commented on my graph, and he didn't like it because he wanted that. See, this data really is, the data is not equally, I mean, there are a lot more values at 0 here than there are over here. So he wanted me to put that line through the 0.0 because after all, so you have to, he says just some adjustments to that, but roughly does the job. Okay, now let's talk about using this information. And okay, so what we want to do is for every single play, we want to define a run value. Okay, and so basically, and here's the formula. The run value of a play is you take the difference, look at the runs, expect the inning, remaining inning for the new state, subtract the runs, expect the inning for the old state, and then you add the run scored in the play. And that's easy to do. This is weird. Ignore that. Okay. Okay, so what I do now is I'm going to basically, I take the expected runs information and I merge that with the data set. And we basically do it twice. We do two left joins. And basically we want to, for every single beginning state, we want to have the expected runs. For every single ending state, we want expected runs. So this code will basically add those run values to these. I won't go into the details here. Okay, so once we've computed the beginning runs and the end runs for each of the plays, we compute the run value, which again is the run value at the end minus the run value at the beginning plus the run scored. Okay. And now we can do things like, okay, we're looking at last season. Who were the best hitters with respect to run value? And we'll look at the cumulative, the sum of all the run values, okay? So for each, the player code is bat ID. Not a real meaningful thing if you look at it, but it's the code for each hitter. For each hitter, we want to compute the total run value. And we just care about the leaders, right? So we want to sort this information in decreasing order by run value. And we want to select that ID and RV. And if you look at Baseball Reference, we know we would look at the top 10, right? So this gives us the top 10. And these are the leaders. Now, if you look at that top 10, that is not real meaningful. Oops, sorry. And so, sorry, I lost something here. Weird stuff in this, okay. Okay, so anyway, what I want to do, did I erase something? I think I lost something here. Somehow I lost some of my data. Okay. So let's see. I'm not used to working with a big font like this. Okay. Okay, let me see. What do we want to do here? So we want to identify the best run hitters.
It's folded.
Oh, folded.
It's like 20 lines.
Thank you.
Yeah.
Beware of folds in our
The
studio.
folds don't get big. The font gets big.
Okay. So anyway, if you look at the 10 best hitters, they're not very meaningful because, okay, so let me look at, there are my leaders, okay. So they aren't very meaningful because we're using these codes, these retro sheet codes. And fortunately, the Lahman package, by the way, the great source of data is Sean Lahman is a columnist for a Rochester, New York paper. And for many years, he's maintained this Lahman database. And this basically gives you season by season data for hitters, pitchers, all sorts of things. And in fact, recently, he's donated this whole resource to Sabre. Anyway, but some people have made this into a R package. And it's called Lahman. And it's recently been updated through 2023 season. Anyway, one nice thing about the Lahman package is it has a people data set. And this contains all the different information about each player, including their retro ID, which is pretty important, and also their first name, last name, their birthday, things like that. Anyway, what I'm going to do now is I'm going to load in the Lahman database. And I'm going to merge the retro ID, the name, the first name and last name, with the leaders thing I just created, and want to merge by this retro ID thing. And this will give us a more useful listing of leaders. And people didn't like people. Let's try, they didn't do it. Okay, there we go. And this is an interesting list because this is from 2023, because many of these people were in the World Series. Ron Acuna, well, he was injured last year. Matt Olson, we don't know, Acuna was also, we don't know where they played for. I'm a Phillies fan, so I ignore the Braves. But we saw Freddie Freeman in the World Series. We saw Mookie Betts. We saw Shohei Ohtani. We saw Juan Soto. And Aaron Judge. Aaron Judge, I think, he was injured last year, right? He didn't play. Yeah. So anyway, so of these top 10, 5 of them were in the World Series? So that's a pretty large number. Okay, anyway, so if you followed this, and of course you can run this, what I just did. And so in chapter 5, we look at things like runs values for different types of hits. There's an event, the key variable in RetroSheet is a thing called event code, which goes from like 1 to 23, I think. And 21s correspond to doubles. And so for example, what was the most valuable double? In the World Series, we saw that a double doesn't always advance the runner 2 bases. There was a runner on second base, and the guy hit a double, and the guy made it to third. That was wasn't that the last game?
I think so.
Yeah. Well, the guy he didn't know the ball was getting caught, and he was. Anyway, so the question is, that could have been the least valuable double in the World Series, probably. Anyway, so you can look at the data, you can look at and see which ones were valuable. Some doubles are more valuable so you can look to see what are the situation where double was most valuable from runs perspective or least valuable. And then what we talk about in the book is the average value. Okay. And of course, we'd love to talk about clutch play in baseball. Now, as statisticians, we all know that there's nothing like clutch ability, but we still can talk about clutch performance. So we can see which players last season were best when there were runners in scoring position. I wonder if teams actually trade for players who are clutch. That'd be an interesting question. I mean, I'm sure, I don't know. Another thing we talk about in our book is we're interested, we talk about, what I've talked about today was run value of different plays. You can also talk about run value of pitches, okay? And so in particular, the pitch count. So we have a function called RetroSheet add counts. And every plate appearance goes through a series of counts. You record if it goes through a 0-1 count, a 1-0 count, a 1-1 count, et cetera. So now you can look at the value of any plate appearance that goes through different counts. Okay. So for example, if you're a pitcher, you'd like the count to be 0-2, right? Because that favors the pitcher. So you would think that the value of all the plays that go through a 0-1 count, 0-2 count should be better from pitcher's perspective than other counts. So what we do in our book is we talk about, you can talk about values of each pitch, each count. And, so really in baseball, every count has a significance. You know. Okay, any questions? I'm not sure how long I've gone here. So, but definitely I encourage you to try things out. I mean, all the materials in the GitHub site.
All right.
Yeah.
Can you hear me? Okay, well I think what we'll just do now is open it up for questions for Jim and David from the audience. I'll walk around with the microphone. Any questions people have? And again, all the material is online, so you can access it after this weekend as well. Any questions?
Jim, can you do like the opposite of the
Okay.
Can you do like the opposite of the per pitch run batted in to look at, what is the best pitch to, consistently throw to keep the other team from scoring? I mean, intuition says it would be.
Yeah, you could definitely, you do it from that'd be easy. You could definitely do a pitch type because, well, okay, you don't have that's a good question. Well, of course, you have to you got to connect that data. Vector sheet doesn't give you pitch types. It just gives you the sequence of pitches. But you could link that. You could merge that with Statcast data. Yeah, and that wouldn't be too hard to do. I mean, yeah, that's a good question.
Did you have to change your model drastically or significantly when they changed the extra innings to starting on second base, et cetera?
I haven't looked at that. Yeah, I think actually I ignored that. I probably should have removed that. Honestly, I'm not even sure how it's coded in Vector sheet, how the ghost runner is coded. I'm just thinking about how it was coded. I don't know how. Yeah. Yeah, that's worth looking into. You don't have a lot of data for that, but you could definitely. We've been doing it for a couple of seasons now, right? So you have a decent number. Interesting. That wasn't used in this World Series. That wasn't.
Hello. I'm an undergrad student. I'm a senior at Santa College, and I was wondering if you guys always had an interest in pursuing data science.
I'm sorry, me or what? Or,
Like both of you guys. Like I was wondering if you had interest in pursuing what you guys like. Did you change your career path, or were you guys always interested?
I was a math major. I just liked math, and honestly, when I was undergraduate, I was a math major. I had no idea what I was going to do with it. And honestly, I never thought I'd be able to connect what I did with sports. I love sports. I'm a tennis player. And honestly, there's not more opportunity in tennis analytics than there is baseball because we need more people working in there's great data now in tennis. But I was fortunate that I had some good stat professors as undergraduate, and I got steered to study statistics. But again, I got hired at Bowling Green. Do you think I worked on baseball problems when I got there? I wasn't dumb. I mean, I wanted to get tenured, right? So no, I basically played the game, got tenured, and then I started saying, well, I'll do what I want to do. I mean, I didn't really, and now things have changed because we have sports statistics journals. You can say you want to work for a team. The opportunities are there. I mean, it's really. And it's much more than baseball. I mean, we'll see examples of other sports. My friend Tim Schwartz has a new book called Pickleball Moneyball. I have mixed feelings about that because I appreciate that he wants to do this, but
I think it's self-published on Amazon.
it is.
Same story almost. I was a math major. Having taken a couple of statistics classes that were required, liked it, kept doing it. At the time, statistics as an undergraduate degree wasn't a common thing. Data science wasn't even a term I had heard. So I don't know. I think I was the first stat minor at my institution. And then I just kept doing it. I graduated right in the financial crisis, so grad school seemed like a good idea. And here I am now still doing it. And then for baseball analytics, I think I got into it kind of backwards. I was kind of a lapsed baseball fan. I hadn't even been watching for a while, like I did when I was a kid and off and on. But I had a student come to me in office hours one day, and he kept asking me these interesting questions. I'm like, "What are you working on?" And he goes, "Oh, well, I kind of managed analytics for the baseball team here." And then I started working with him on that, and now I'm doing this. So I blame him for that. So if anyone ends up working for the Astros, go blame Charlie Young. It's his fault.
Other questions? No.
Hello. So for those of us who are not like traditional, like for me, I'm a geomatic student, so like I'm not really traditionally under like the faculty of math, like CS, like statistics. Like, is there what advice would you give me if I want to like work for like a sports team because of like the fact that I'm not really under like the traditional major?
What's remarkable about, I mean, I think I'll be working for the Astros. The head of their group has a PhD in physics. That's not uncommon. I mean, they come from a wide variety of backgrounds. And so I think what I would say is start doing something. I mean, what you can do or present is probably more important than your formal background. I mean, if you can do a project or post a blog or something, show it to people, show them what you can do.
Yeah, I would also add to that, one of the individuals at the Astros, Adam Brody, has a PhD in philosophy from Carnegie Mellon. Now, the caveat to that is philosophy at Carnegie Mellon is pretty dense math theory, so pretty technical knowledge, but still wide variety of backgrounds now of individuals working for teams, not just stats, data science. And it's good, different views of how to approach various problems. Other questions?
Thank you.
How do you see the field of sports analytics evolving in baseball?
Yeah. Well, I think one thing is right now there's a big interest in. Yeah. One thing is that there's a lot of interest in body. Like I think we got to understand injuries better. I mean, look at the pitching epidemic of Tommy Johns. That's just not right. I think that we're going to figure out more about parts of the body, how preventing that a little more. That to me is the next big thing to sort that out. Besides baseball, there's the football groups right now. Some teams in baseball have big groups of analytics people. That's not true for other sports. Football is just getting started. Hockey, soccer to me is a big frontier because there's more interest in soccer than any other sport in the world, right? So I think you're going to see things expanding. The idea of expected runs is being used in other sports, right? They give it different names, but that concept is being used in a lot of sports.
Yeah, I think I'll just... This turn on. Okay, I'll just add to that. Over 10 years ago, I was an intern for the Pittsburgh Pirates, data analytics intern. And so this was pre-StatCast era. And what I had to do for all these games that took place was I charted where everybody was on the field at the start of a pitch. Then the ball would I would have to stop the camera when the ball crossed home plate. So this was the morning after every game, basically. It was a great way to start my day. And I would chart where's everybody at when the ball crosses the plate, or if someone makes contact, like if the bat made contact, I would make sure like I timed the pausing of the video correctly. And then the ball would go into play, time the pause of the video again, mark where everybody was at. And it was all the manual data collection of basically to go into shifts for the team. They don't do that anymore. There are camera systems automatically tracking this type of information. And at the time, I was just an intern in a group of effectively actually 2 full-time people in the analytics squad. But now, I mean, the Pirates themselves are over a dozen individuals, but you have teams like the Dodgers, the Yankees, who matched up in the World Series. They're mini tech companies effectively of over 20 data scientists, analysts on staff, and that doesn't count another dozen or 20 web developers that make applications or websites. So it's very different now than what it was when I was in undergrad 10 dozen years ago. And so it's definitely changed. But to Jim's point, football teams, for instance, more so are at that level, I'd say, that baseball teams were at a decade ago. So they're still growing, and there's going to be more and more growth as the technology keeps increasing, and teams need to be able to keep up with all the data that's coming in.
I like the mini tech company framing of it. And I think something that comes with that is with that plus the growth of these teams is specialization. Like people that are an expert in like one weirdly specific thing, but if you can utilize it to help win baseball games or any other sport, like it's useful. Yeah. So I think it's, just being a general data scientist. I mean, we're hiring those people still, but like, I think specialization is a key thing now.
Other questions? All right, it's 6:50, so thank you all for joining us tonight and sticking around for a little bit longer and being patient with us as dealing with microphones, getting things started. Let's thank again Jim and David for their excellent workshop. All right, and make sure to grab any remaining pizza. I don't want any pizza slices remaining down here. So if you're a student, just take a whole box. I'm dead serious. Just eat it at whatever pace you want. I'm not controlling that. Otherwise, we will see you tomorrow morning. Thank you again.